Hello everyone, I am Nicolas Isoart and I will talk about a KOP-based constraint for the TSP. So the traveling salesman problem is a NP-hard or NP-complete depending on the variant problem, which have for data a list of cities and the distance between each pair of cities. It is constrained by two constraints. The first is to visit each city only once, and the second is to find the shortest cycle. Well-known heuristics solving this problem are the tour improvement algorithm. It starts from a non-optimal tour and it improves iteratively the non-optimal tour with, for instance, the k-opt algorithm. The heuristic works as follows. It starts from a tour T, and for each pair of the tour E1 and E2 in T, it removes the two edges and then it reconnects T with two other edges. So, for instance, if we have the circle as the tour, we have x1 and x2 and y1 and y2 as an edge of the tour. So if we swap the edges x1, x2 and y1, y2 with x1, y1 and x2, y2, if that swap leads to a shorter tour, we can decide to apply that swap in order to improve the tour. This algorithm can be generalized for k-opt, that is a subset of k edges in the tour. Conversely to heuristics, the CP model does not have a tour to improve. However, it has mandatory edges that can form a path. Therefore, the purpose of the CP model is to find a tour going through this path. However, if a path is not optimal, it means there is a k-opt, then the path cannot belong to the optimal solution, and therefore this path is not valid, and then we detect an inconsistency. So in the full video, we'll show an algorithm to perform a consistency check, to filter some edges, and an incremental algorithm in order to perform all this operation. We will show that these constraints lead to an improvement of a factor of 3 in the solving times.